Alright, hello beautiful people. Today we're talking about how do we measure and compare segments. And we're going to do two different postulates and talk about them. So just as a refresher, a postulate, remember, is like a theorem without a proof. So it's just a statement without a proof. It's something that people take as true without a proof. So it's like, the sky is blue. That's a postulate. It's a statement that doesn't require proof. It's some of the starting grounds of geometry. Okay. So our first postulate that we're going to talk about is called the Ruler Postulate. And the words that we use in math for what the Ruler Postulate means are kind of complicated. However, it's actually just really, really simple, like something that you already know. So I'll write the layman's terms in the left-hand side. All right, the Ruler Postulate says that the endpoints on a line segment can be matched one-to-one with the real numbers. The real numbers are the set of all numbers that you know and love that exist in the real world, like 1, 17, 12, and 37 seconds, or 4.6532, whatever, and pi, all real numbers. And then the distance between endpoints is called the segment length. So in layman's terms, or in real-world terms for people who are not exactly mathematicians, basically it says that you can measure a line segment with a ruler. I mean, you can measure it with all sorts of other things also, but basically it just says you can measure a line segment with a ruler or with something else, because the distance between the endpoints is the segment length. That's it. Which again is something that you already probably knew. You probably were like, oh yeah, this line segment has length because it's not infinite. It is a finite amount, which means we can measure it. So every year as you're learning more and more math stuff, you learn more and more notation and stuff about it. So basically, the vocab is the notation that comes with this. So I'm going to call this notation station. And we will be using notation station throughout the year to basically just signify new stuff that we learn to write. So notation station, if you have like AB, this means line segment AB. Line segment. Okay. If you have MAB, that basically means find the measure of AB. Find the length. Okay. And if you have AB without the line on top equals something, then you know the length. So AB represents the length of line segment AB. Okay, so notice the only real difference here is that line segment symbol on top. The line segment symbol just means this is the line segment, the name of the line segment. Without the line on top, it means this is the length of that line segment that's named AB. Okay, so again, those are like really teeny tiny differences between those two things, but it's super important to note because when you get tests, quizzes, practice work, etc., you're going to need to know whether they're asking for a length or they're asking for congruent statements. So very important to have this notation station in your math notes. Okay, and then the next thing I want to talk about that's going to relate to the ruler postulate is congruence. And congruence is when two segments are equal or have the same length. Okay, so for example, if I had a line segment over here that was from here to here, I called it AB, and then I had another line segment that was again from here to here, and I called it CD, then I could tell that they're equal if I used a ruler, and then they would be congruent. So we're going to do another notation station for this one because we have to know how to write congruence. So, all right, so I've got AB is equal to CD. This means their lengths are equal. And then I have AB, the line segment, is congruent to CD, the line segment, which means that they are congruent. Okay, the line segments are congruent.